Okay, so today's problem is house robber. So let's start by understanding the problem and then we'll move ahead. So the question says Mr. X is a professional robber planning to rob houses along a street. Okay, so each house has a certain amount of money hidden in it. All houses along the street are arranged in a circle. Okay, so point to be noted, all the houses are in circle format, right? So that means the first house is the neighbor of the last one, correct? Meanwhile, adjacent houses have a security system connected and it will automatically contact a police if two adjacent houses were broken on the same night. So that means if two neighbor houses are looted at the same time, like one by one, one after the other, so the security system will call police in that case. So you are given an array of known negative integers representing the amount of money each house have. So your task is to return the maximum amount of money Mr. X can rob tonight without alerting the police. Okay. So our main task is to return an array having the maximum number of looted amount in it, so that such that we cannot loot into alternative houses, means the neighbor houses. So let's understand this problem more clearly. Okay, so basically, let's suppose we have few houses with us, right? So houses are arranged in a circular format. Now the condition is we cannot loot two neighbor houses together. That means if I'm going to loot this house, then I cannot loot this and this house. Means the neighbor houses cannot loot together, right? And if I'm going to loot this house and this house, if I'm going to loot this house, then I cannot loot this house and this house. Okay, I hope you got an idea on what are the constraints for this problem. So how we going to approach this? Let's start by making a choice diagram. So we have a house, so we have two options here. Either that house is adjacent or that house is non-adjacent. If the house is adjacent to the previous one, that means we cannot loot it, right? And if the house is non-adjacent, that means we have two options. Either we can loot it and we cannot loot it. So this is the problem we have. Okay, so now how we are going to use DP here, that is a big question. So for using DP, we have two conditions, if you know. First is it should have overlapping sub problem. Okay, and you must be very well aware of the condition that if some question have some overlapping sub problems, that could be easily solved by recursion, right? But now how we can apply DP here? Like if we have overlapping sub problems, we can easily solve it with recursion. So why we are going to use DP? That is the question. So for DP, if we get if we get some kind of text in the problem, like you have to maximize a problem, you have to minimize, you have to maximize the solution, you have to minimize the solution, or find the max or minimum. So such type of question, if such words are contained in particular question, so that means we have to optimize the recursion, right? So recursion might solve some problems that we have already solved. For example, we have some question and we gave two solution to it, right? And this solution as well, we can give two solutions for this as well, right? And let's say this solution is same as this solution. So here in this case, we have already solved this. So why are we going to again solve this problem? So here we can optimize some complexity. We can optimize the solution. So in this way, we are going to use DP. So DP helps us optimizing the recursive solution, right? So in this question, we have overlapping problems because we have a choice in a house that either we can include it or we can exclude it, right? So such choices give us tell us that we can use recursion in this question. And in question it is already mentioned that we have to maximize the looted amount, right? So we can use DP in this case. Got it? Okay, so now let's come back to the problem. So let's say I have I have an array 3, 2, 5, 6, 9. Okay. Now for every house, this is the amount that every house contains. Okay, this is the amount that every house contains in it. So for every house we have two choices: either we can include it or we can not include it. Okay, so in case we include this house, so we cannot include the next house, right? Correct. I hope this is clear. If we are going to include this, we cannot include this house, right? So the condition will be, if we are going to include a house, the value of a house, we are going to include a value of a house, then we cannot include the next house, right? So in such cases, what we can do is, let's say we have some indexes I. The indexes will be 0, 1, 2, 3, and 4. So these are the I, okay? So if we are going to include these conditions, if we are going to include these, so in that case, this means that we have to increment the index by 2. We have to increment the index by 2. Got it? So if we are going to increment the index by 1, we will go to next neighbor, right? We'll go to the next house. So that is the constraint here. We cannot basically loot the neighbor houses, right? So we must not include this. So because of that, so to not include the next house, we are incrementing the index by 2. So this is the case where when we are including a particular house. And in case we are not including a particular house, what we will do is, so we are not included, right? So the value will be 0. We are not looting this house. So the value that we'll get will be 0. And index will be I plus 1. So in this case, we are not looting a particular house. So that means the next house can be included. That's a choice, right? So we can increment the index by 1, and in this case we must increment the index by 2. So these are the two very basic conditions that one should keep in mind while coding. So only these two conditions will be required to give an answer for this question. So that's all, right? So let's again understand this with the help of an example. Suppose I have an array 3, 2, 5, 5, 6. Okay, 3, 2, 5, 5, 6. Now these must be arranged in a circular order. That means 3, 2, 5, 5, and 6. So if you can observe, this is the index 1, this is index 2, this is index 3, this is index 4, this is index 5. The last index and the first index are also neighbors. Okay, so if we are going to include the first index, we must not include the last index. And in case we are going to include the last index, we must not include the first index. This is because of the constraint that we have with us, that we cannot take two alternative houses together. We cannot loot two alternative houses together, right? So in such a case, what we will do is, we'll just have a constraint that if we are going to take this array, we're going to find the maximum looted amount from this array, and then we should calculate the maximum looted amount from this array, and out of these two arrays we'll find the maximum. That will be our answer. Got it? Because we cannot take this whole array altogether, right? The reason is 3 and 6 must be neighbors, right? And we cannot consider it in that way. So if you will see clearly, the problem that is here is, find maximum alternative sum in array. This is the same problem. We have to find the maximum alternative sum in array, right? We cannot take two alternative arrays here, and we need to find the maximum sum also. Okay, so let's understand this again. We'll break the array in two parts. First, in first array, what we'll do is, we'll include the first amount, means the first house will be included and the last house will be excluded. And in the second array, we'll exclude the first house, right, and include the rest of the houses. So that are the two cases. And after doing that, we'll just solve the problem using this question: maximum alternate sum in an array. And that could be easily solved by these two conditions. If we are going to include a house, then we'll not include the next one. That means then we'll increment the index by 2. And in case we are going to not going to include a house, so that means we can include the next house, right? So we are just going to increment it by 1. Got it? So let's code this now. Okay, so the first condition that I told was we'll be dividing this value in houses array into two parts, right? And in the first part, we'll include the first house, and in the second array, we'll just include the last house, right? So let's do it. So first of all, let's write the length of the array, right? So that will be n equals to value in houses dot length. Okay. Now we'll create two arrays as discussed. So first array will be array list of integer, and let's name this as array 1 equals to new array list. Got it? And let's just copy it and rename it to the second array. Let's name it to array 2. So now we'll run a for loop and we'll divide the arrays in two parts. So for int I equals to 0, I is should be less than n, and increment I. So if I is not equals to n minus 1, so that means in this case I'm not including the last house. So I'll just add array 1 will be equals to array 1 dot add value and house at ith position. Got it? And similarly for the second array also, but the condition will be I should not be equals to 0. That means in this case I'm not including the first house. Got it? And let me write this out. In first case we are not including the last house. Got it? And in this case we are not including the first house. Got it? And now what we want to do is we just need to find the maximum of these two cases, right? So we'll just return maximum of these two arrays. So let's call one more function where we are going to find the alternative maximum solution. Okay, let's write it solve, and I'll just pass it the parameters as these array 1, and the size will be n minus 1 because we are removing one house, right? And in the second case we'll just call the solve function with the parameters array 2, the second array in which we have not included the first house, right? And the size will be n minus 1. Got it? So these will be the cases. Now let's start with the solve function. Now in solve function it's very much clear that we are going to use two condition. The first condition that we are going to use is the houses that we are going to include that one particular house. In that case what we are going to do is we'll just increment the index by 2, and in the other case we'll increment the house index by 1. Got it? Okay, so the two conditions are, if we are going to include a house, that means we'll increment the index by 2 for the next house to include the next house. And if we are not going to include the house, that means the value that we loaded will be 0 from that particular house. And then in that case, we can easily load the next house. So that's why we are just incrementing it by 1. Okay, just remember these two conditions, very important. Now let's make the next function that will be static long, and the name we are going to give is solve. We already discussed. And an array list, right? And an array list of type integer. Array list of type integer. Got it? And we'll name it as array. Okay, so now you can see here the first parameter that will give is array 1, and the second that we are going to give is n, means the size of the array. So int n, that's right, int n. Got it? Okay, so first of all, let's write the base condition. So base conditions are basically the lowest possible values that we can give, lowest possible case that we can have. So suppose if n is less than 0, means s is less than 0, that is invalid case, right? So we'll just return 0 in that case if that happens. And if n is equal to 0, that means there is no house, right? So there can be no loot. So basically we just return array dot get the value that we have at 0th position. Got it? Now we have two condition: either we can include a house, okay, and the second is either we should exclude this house, means not include that particular house. Got it? So okay, so the first condition is include. So if we are going to include, we must add the value that we have loaded in that particular house. Got it? So that will be array dot get at n, right? Array dot get the amount that we get from the nth house, plus we're just going to add this amount. We are just going to add this amount and then call the function again, and we are just going to pass two parameters here. First with the array itself, and n will be n minus 2. Now this is the same condition that we have here, this one, okay. If we are going to include a house, value of a house, the looted amount from a house, then we are just going to increment the value of I by 2. And here in this case what we are doing is we are moving from left right to left direction. Got it? So in that case we are just decrementing it. That will be a similar case. So second case will be we are not going to include, so the value that we are going to get will be 0 plus solve. We need to solve and give the array list and the index, that will be I minus 1. So these two condition are the same that we discussed. First one is the if we are going to include the value, we cannot include the next house loot, right? So that's why I'm writing I plus 2. Similarly, if we're not going to loot the house, the looted amount will be 0 and the next house we can loot, right? So these will be the two cases here. Got it? Now we just need to return maximum of this include and exclude. Now that is all about the recursive solution. Just note one thing: we haven't included dynamic programming here. We're just solving this question using recursion, simple recursion. Now I'll just tell you how you can convert your recursive solution to a dynamic programming solution, DP. Using DP, how you can solve this very easy conversion that we need to learn. Just a few step changes that we are going to change in this particular solution. Got it? Now if you can observe here, I'm just writing n minus 2. This thing might give array index out of bounds. Reason? In case n is 1, so if you are going to do 1 minus 2, what it will be? It will be a negative integer, a negative value that we'll get, that is not valid. So this might give array index out of bounds. So for that what we'll do is we'll just keep a check if n is greater than 1. So in that case we can do it n minus 2. Got it? So we'll just put this line in this if condition, under this if condition. So one more thing, we are using this include here in this line. So if we are limiting this include in the scope of this if condition, we might not be able to use it here. So let's define it upwards. We'll just write it over here, include, and we can give the initial value also. This is not dependent now, so we can give it here. Got it? And here include, we will add include here. Include equals to include plus, then we can solve, we can call the solve function, and we will decrement the index by 2. That's all. Let's try to run the solution now. Okay, so okay, the possible loosey conversion. Okay, so I haven't noted that we need to return it in long. Okay, so we must change this to long, and this also to long, and n minus 1. Got it? Now let's try running this again. Cannot find symbol. The spelling is wrong. Include. Okay, one more issue we made. Okay, this is under the scope of this for loop. Let's cut this and we'll put it here. case we should include if our n will be 1, that means only one house we have for the loop. So that in that case what we can do is we can directly return the value and house at 0th position. So let's try running this again. Okay, one more mistake here. N should be greater than 2, right? So to decrement by 2, we must check if it is greater by 2, right? Then only it will give a positive answer. Let's try running this. Okay, these are the custom test cases. Let's try here again. Okay, the answer is correct. But if I'll submit this solution, this will give me time limit exceeded error. The reason behind this is we are not optimizing it. We are resolving the questions that we have already solved. So just to ensure that we do not get TLE, we might solve this problem using dynamic programming. So now let's understand what steps we are going to follow to convert a recursive solution to a dynamic programming solution. First of all, what happens in a dynamic programming? Let me expand it a bit. Okay. So in dynamic programming, what we do is we just try to store the solution of the previous subproblems in a 1D or 2D arrays, right? So instead of calling here solve again and again, instead of calling or making the recursive calls, what we are going to do is we are just going to call the answer that we have stored in that particular position. So that was an overview. Let me just write it again. This will be similar. Okay, this will be similar. We are just going to make the dynamic programming call here. So in the solution, if n is equals to 0, we just need to return the array at 0th position. So that means dp at 0 will be equals to array dot get 0. So I've just converted it into the dynamic programming. One more thing, we just need to define the array first, dynamic programming array. So int dp will be equals to new dp of length n. Got it? And we don't need this line now. So now here you can see one thing. If n is equals to 0, we are just returning the value at that particular position. Got it? So same thing we'll write in DP also. At 0th position, I'm just going to store the value at the 0th position. That's all. So we can remove this line as well. Got it? And for the include and exclude, what I'm doing here, for the include and exclude, I'm just making the recursive calls again and again. This is the thing that I need to stop. And instead of this, we can just call the dynamic programming. We can call the DP array that is at n minus 1 position. That means I can call DP at n minus 1 here. This will give me the same answer because we are storing every sub problem with us. Got it? So n minus 1 position answer will be the answer to this. And here in this case, similarly in this case also, as we are storing the sub problem, so here the answer will be dp at position n minus 2. That was all. So let me just comment out this code. I'll just convert this code first. Okay, and then we'll remove this part, right? So let's start one by one. I'll just make a for loop starting from 1. I should be less than n and increment I. So the very first thing that we need to change is the include, right? So here the include will be equals to array dot get I array dot get at ith position. Okay, and this line is changed. This will be, although this will be very similar line. Now the next is if n is greater than 2, then we have to make a recursive call at by decrementing the index by 2. Okay, So instead of that, what we are going to do is we are just going to fetch the element, fetch the solution that we have already solved, and that is at n minus 2th position, means the decremented position. Got it? So I'll just write here, if n is less than 1. Okay, why I'm writing 1? Because we are starting with 1. So that means technically it is same. N is already 1. So this will not be less than 1, right? So in this case, we can write n is less than 1. So in this case, what we'll do is include will be equals to include plus dp at n minus 2 position. Okay. And similar thing we'll do for the exclude. Exclude will be equals to 0, means we haven't included any current value from that house, plus dp at n minus 1. Now we will just return, so now instead of returning, we'll again solve, we'll again store it within the array. So what we'll do is dp at ith position will be equals to maximum of include and exclude, and that's all. At final stage, what we are going to do is we'll just return dp at n minus 1. That's all. So just two changes. Instead of returning everything, we'll store everything in dp, and we will utilize that stored value, means the stored subproblem solutions for the future problems. For example, here, instead of making the recursive calls, what we are doing is we are just fetching the value that we have already solved. We have already solved it in minus 2 position. So in recursion also we do same thing. We just call the function and just calculate the answer that we have with the index if it is n minus 2, correct? And in dp, what we are doing is we are just fetching that stored value. Got it? So every sub problem we store, so we do not need to resolve again and again. So this will solve our time complexity. So you're using dynamic programming, the time complexity is big of n, and this space complexity is also big of n, while in the recursive it is 2 to the power n, which is a huge difference. So that's why it was giving the tle, right? So I'll just remove this code. So one more thing, we need to return in long, right? So we need to make this in long, equals to new long of size n. Okay, one mistake I've made here. So instead, the problem will be I should be greater than 1, right? And instead of using I, because we are not using static, right? We are using I, means we are traversing the whole array, 1D array that we have made, the dynamic programming array here, right? So we'll be using I instead of N. Yep, that's all. Let's run the code. Let's run our solution. Okay, let's rerun this. Okay, the solution is correct. Let's try submitting this now. Yeah, I hope you got the idea. Thank you.